Let's now see how to dynamically allocate memory. Let's open a new file, file.c. The idea is to define, as a pointer, a variable whose size hasn't been defined yet, and that'll just contain the address of a memory area that we'll ask the system to provide us with. Let's declare a pointer, char star, more specifically a variable str, that's a pointer of type char star. So, we're defining a pointer, not a fixed size string, and we'll make the string size vary. In order to make it vary, we'll use a define that we'll call len, for example, and define it to 42 bytes for now. So we're simply going to use a malloc system call to which we'll pass the size that we wish to allocate. And then we'll scan this character string and fill it with random characters. For example, we'll tell it to display the 0 character increased by %10, which will do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. Now, let me correct a few things. First, we have to take care of the size we pass to malloc. The idea is to ask a malloc of 42. Our string has a size of 42. We want a string made of 42 characters, so we have to think about the /0. We'll add 1 to our malloc size. Malloc expects a size in bytes. We'll assume that 1 character equals 1 byte. Just to be sure, we're going to use the code size of. For example, to do a size of char, which will multiply by the number of characters we need, a size of will give us the variable size in bytes. For example, instead of having a string, we'd like to have an array of ints, integers. We could do the same with int star str, but that would mean that here we'd have to replace that by an int. So to make it easier, we'll put star str. So that size of will simply take the same type as str. It'll allow us just to change the type here and prevents us from having to change it everywhere in our code. Let's have a look. At malloc's man, to avoid warnings, errors, or any other problem, let's include the file defined here. stdlib.h. As it says in the man, we can notice that malloc's prototype returns a void star. Void star is an address without a type, but str does have a type, so we're going to have to cast it in order to give the type char star to what malloc returns. So, we do have a type char star that corresponds to str, malloc of the size of a character, multiplied by the number of characters we want, plus 1 for the \0 we'll place here. Here I is worth len, so we're at the end of our string, which will end with a \0. Once we've done all of this, we're going to display our string. Our string is displayed from 0 to 41. Because the index starts at 0, all 42 bytes are here. We'll just add a line break. It'll be a bit prettier. Let's now change our size, for example. We'll set it to 21 instead of 42. Recompiling, relaunching, and our string's now 21 characters long, and the allocation worked fine. We didn't even have to change anything in our code. We could have done something like this, but the problem here is that we allocate memory in a stable and definitive way. With our method, we'll be able to temporarily take memory and then free it. So let's remove the display, because otherwise it's going to cause problems. And simply put a very long string of 42 million bytes. So it's going to require 42 megs of memory. Or a little less, because 1 million bytes is 1024 times 1024. So we do the same, we allocate 42 megabytes, we fill up the 42 meg, we simply don't display that on the screen to avoid problems. We'll just add something here to stop our program. We'll kill it in the end to get rid of it. In order to check with top, the memory used by our program, we don't need ft underscore put str anymore. Let's relaunch our program in the background so that we can see in top the memory used. It's in the background, it's in its while one running. Here it is in top, and we can see it's using 40 megs of memory. Let's let it run. And now, going back to malloc man, we can see that there's another system called free, which will allow us to free memory previously allocated by malloc. Free takes malloc's void space star and doesn't return anything. It's still the same define. So what we're going to do before our while loop is call free and pass it str, which is the address malloc has returned a few lines before. And compile this into a.out2. Let's launch this a.out2, still in the background. And now we can do a comparison in top. Our first a.out still has its 40 megs of memory, and a.out2 has gone down to 132K. We freed the memory used by malloc. So this will allow us to perform occasional memory allocations, example for work, or for chained lists, or for things that don't have a size at first, and to which we can't set a size in the program, such as strings, arrays, and chained lists. That's it for malloc.